Chainlink VRF is one of the most popular tools used by blockchain devs to feed random numbers into their contracts. Yes, you could hash together a bunch of block data to get a random number, but that is ad hoc at best and definitely not production level code in this day and age. This video will be a blockchain developer's overview to Chainlink VRF, a decentralized and verifiable generator of random numbers. In the next few minutes, we will quickly go over how Chainlink VRF works and will then look at an example to see how you can quickly integrate Chainlink VRF into your smart contract. Chainlink VRF is powered by two key components, an on-chain coordinated contract and the off-chain Oracle network. The coordinated contract is responsible for making the Oracle network aware of new randomness requests and for verifying that the random number received back is valid. The Oracle network is responsible for generating the actual random numbers. However, the Oracle network is an off-chain entity you will not be dealing with directly as a blockchain developer. Here is an overview of the general process of getting back an actual random number from Chainlink VRF. This whole process is initialized by your contract calling the request random words function on the coordinated contract. This function returns a request ID that uniquely identifies each randomness request. Triggering this function results in the emission of an event that notifies the off-chain Oracle network of your request. The network then waits for a few blocks and returns a random number. And yes, it is inevitable that the random number is generated after a short while. The process is not instant. The generated random number is returned to the on-chain coordinator contract. The coordinator first verifies the validity of the proof. If the random number is valid, the coordinator then calls the fulfill random words function on our contract. Please note that the fulfill random words function is defined on our contract and is only called back by the coordinator contract after the random number generation process is complete. This function won't be called by our contract or any other user. Any logic in your contract that is directly controlled by the generated random number should be executed within the fulfill random words function. Now, this was a brief conceptual overview. Let us look how we can plug in Chainlink VRF into a smart contract by randomizing the mint function on our ERC1155 contract. Now, this is what a regular mint function looks like. We allow the user to choose a token ID of their choice and we mint them that token from our collection. As you can see, this function is pretty straightforward. We just check and update a mapping to make sure each user mints exactly one NFT and call the actual mint function from the OpenZeppelin library. In contrast, to plug in Chainlink VRF while maintaining the exact same experience for the user, we will need to break the mint function into two parts. The first part will remain the same. The user will still call the mint function to claim an NFT from our contract. Our mint function, however, no longer calls the actual underlying mint function. It instead calls the request random words function from the coordinator contract by using an instance of the interface that was initialized in the constructor. We then map this unique request ID that was returned by the request random words function to keep track of each user's mint request. You will note that the user wasn't actually minted an NFT via this function. That is because it takes a certain amount of time for the VRF service to return a random number. We can configure this time within some limits to our liking by setting the value of the block confirmation variable. In fact, Chainlink is quite liberal in giving devs the freedom to decide how their contract will use the VRF service. You can make those choices by giving suitable values to all these variables, but we won't be going over that part in this video. For now, keep in mind that we have just sent a randomness request to the VRF. We now need to write the code that allows our contract to use the random number that will be returned. And for that, we need to define a function named fulfill random words. The coordinator contract, while calling this function from our contract, will pass the request ID and the array of random numbers as parameters. Do note that the array returned to us will have only one element, one random number in each request, because that is how I chose to set it. Firstly, we get back the address associated with this request ID. Then we cut down the large random number returned to us into a number between 1 and 100. Now, if this final random number is 100, we set the token ID to 1. Else, if the number returned is divisible by 3, we set the token ID to 2. Otherwise, we set the token ID to 3. In a nutshell, what this means is that the token IDs 1, 2 and 3 will have their minting probabilities set to 1%, 33% and 66% respectively. Lastly, we mint an NFT with this final token ID by calling the underlying mint function, and we also update the minted mapping to make sure each address is able to mint just one NFT. And that is it. No, really. This is how you would plug in Chainlink VRF into your 1155 smart contract by splitting up the mint function. From the user's perspective, there is very little change. They still just call the mint function like before. The only difference now is that they need to wait a little while before actually being minted an NFT. Now, please note that this was a very fast-paced overview of what it looks like to actually use VRF in a contract. I did not want to do an A to Z VRF tutorial because that has already been done many times before. If you want to check out a full tutorial on VRF, you can see my blog that has been linked in the comments. In there, I go through everything: setting up a VRF subscription, building a VRF contract, and even testing that contract, all using Foundry. Now, if you found your Solidity skills or knowledge to be lacking in general, I highly suggest to check out this full blockchain developer course on Patrick's channel. Easily the best tutorial out there on blockchain development. With that, I'll be ending this video and I'll see you in another one.